Welcome to Lesson 10.5. We're going to be talking about how to find the areas of regular polygons and triangles using trigonometry. Now, the big thing we're going to have to remember, everybody's favorite acronym, SOHCAHTOA. Okay, if you remember what these three things mean, you will do just fine in this section. If you don't, you might want to revisit the previous lessons where we talked about this so you can refresh your memory. First example we're going to be looking at is we've got this regular octagon with 8 sides, and each side is 7.5 centimeters, and our job is to find the area of this octagon. So what we need to do is we need to find our apothem, and how we're going to do that is we start with connecting these opposite corners. Okay, because what we're looking to find is this central angle down here. Now, the whole circle again is 360 like it was in the previous lessons, and I've got 1, 2, 3, 4, 5, 6, 7, 8 different pieces. So if I did 360 divided by 8, it would tell me that each one is a 45-degree angle. So how that's going to help me is when I draw my apothem from my center, it goes straight down and making a 90-degree angle. And what that's going to do is that's going to cut this 45-degree angle in half. It's going to make it a 22.5-degree angle. So if I pull that triangle on the left out, if I pull it out here, I've got a 22.5-degree angle up here. I cut the 7.5 in half as well, so it becomes 3.75, and this is a 90-degree angle. What I'm looking for is this value of x. Now how I'm going to find it is I'm going to use trig. Now I'm given this angle up top, I know the opposite side length, and I'm asked to find the adjacent. The trig function that works with opposite and adjacent is tangent. So if I take the tangent of 22.5, it would be equal to the opposite over the adjacent. Now to solve for x, I put tangent over 1 and I cross multiply. So I get 3.75 is equal to x times the tangent of 22.5. Divide both sides by the tangent of 22.5. And I get that x is equal to, when we type in the 3.75 divided by the tangent of 22.5, I get that x is 9.05. So my apothem in this problem is 9.05. To find my perimeter, there are 8 side lengths of 7.5 each. So I take 8 times 7.5, and I get my perimeter is 60. So my area formula, 1/2 times my apothem of 9.05 times my perimeter of 60. And when I do that, I get an area of 271.5 square centimeters. That's how we're going to use trig to find area of regular polygons. So again, the steps that we did to get this, and you might want to jot this down. The first thing we did was we found our central angle. We found it to be 45. Then we used that to find our apothem. We cut that 45-degree angle in half and formed a right triangle with a 22.5-degree angle and a 90. We found the apothem using tangent. And then once we had the apothem, we took the apothem and the perimeter and we plugged it into our area formula to find our area. Our next example, we've got a hexagon with a side length of 15. So again, we're going to find our central angle, which is right here. We can take 360 divided by 6. And that'll get us that it is a 60-degree angle as our central angle. Drawing our apothem in cuts our angle in half, so now this is only a 30-degree angle with our 90. So if I pull that triangle out, it is a 30, 60, 90-degree triangle, and this bottom side is now 7.5. So I am looking for this length here. Again, we can use tangent. The tangent of 30 is equal to the opposite over the adjacent. Cross multiply. I get 7.5 is equal to x times the tangent of 30. Divide both sides by the tangent of 30. And we get that x is equal to, we'll say 13, because it's 12.99. We're going to round that up to 13. So I know my apothem is 13. My perimeter, there are 6 side lengths of 15. 6 times 15 gives us 90. So my area formula is going to be 1/2 times my apothem times my perimeter. And when I type that in, I get an area of 585 square inches. This example, we're going to be finding the area of a triangle. Now remember, area of a triangle is 1/2 base times height. So I've got my base in this triangle. I know my base is 12, but I don't know what the height is. I don't know this distance right here. However, I am given this 36-degree angle. So what I can do is I can use this 36 with the opposite side length and the hypotenuse. I don't want to use this 12 because 12 is the whole length and I'm only using the part until my hypotenuse, and I don't know what that length is, so I'm going to stick with using the 8 up here. So opposite and hypotenuse, that tells me to use sine. So I'm going to take the sine of 36 degrees, it's going to be equal to x over 8. I put the sine over 1 and I cross multiply. I get x is equal to 8 times the sine of 36 degrees. And if I type that into my calculator, I get that x is going to be 4.7. So I know my height is 4.7. So plugging that into my area formula, I've got 1/2 times my base of 12 times my height of 4.7. And that gets me an answer of 28.2 square centimeters. Our last example for this lesson, we've got another triangle. So again, I'm going to have my area formula, 1/2 base times height. I do know my base, it's 5.6. I don't know my height, so I'm going to draw in my height here, making a 90-degree angle. I'm going to label it as x. So I'm given this 70-degree angle here. Now again, I want to use my height that I'm looking for, and then this side length here, my hypotenuse of 2.6. So how that's going to look, opposite and hypotenuse, I'm using sine again, so sine of 70 is equal to x over 2.6. Cross multiply, I get x is equal to 2.6 times the sine of 70. And if I type that into my calculator, I get that x is about 2.4. So my height is about 2.4. So if I plug that into my area formula, I've got 1/2 times my base of 5.6 times my height of 2.4. I get an answer of 6.72 square yards.